बोल दिए थे, इसलिए बोलते हैं गलत नहीं करो।
रुको, चुप रहो।
है
हेलो, ऑडिबल?
Yes, sir. Good morning, sir.
We also cover the questions of three-phase also we do, okay? So today we complete class. This is the old question which was asked frequently. Now there is a new recent question was also there. This question. Okay, this is currently asked the question. We already covered this fourth part A, part B, and this are same questions. See, I want to first to explain. What is the equivalent circuit as referred to transformer equivalent circuit as refers to primary side status side. We have a primary resistance, primary reactance, then you have a magnetizing branch. Okay, magnetizing branch. Then this is inductor, okay. Then you have a secondary resistance, secondary leakage reactance. Let us it is open. Okay, open. Here we apply the voltage V1, rated voltage at rated frequency. Then there is a current it take, but this is R1, X1 at this node, I node, X node, sorry, this is R node, X node. Now this no node current has a two component, one, two. One is active, passive, or loss component and a magnetizing component. It is responsible for to magnetize the core, produce the flux. So this is useful current, but this is a loss. Now at no load, here current is I2 dash 0, R2 dash X2 dash. Okay, this, if load is there, then we connect the load, then this current will be there. Now in this case, it is 0. Okay, that's why here this I1 is only I node up to at no load. Now ideal transformer for ideal means loss free ideal transformer. So in ideal transformer there is no winding as a no resistance, negligible resistance. We neglect the primary resistance and secondary resistance. there is no leakage flux. 100% flux is core only. 100% coupling between primary and secondary. Okay. Flux produced by primary link 100% with secondary. These are zero, means primary impedance and secondary impedance are zero. Z1, Z2. Okay. Then there is loss free, no iron, means infinite core. There is no core losses, so this part also zero. Can you draw the what is the ideal transformer equivalent circuit? Only this much. Okay. Now here we apply the primary, you apply the voltage V1, rated voltage. Then there is a current is flow, but at no load it take only magnetizing current. So आपकी I1 is equals to I mu only. Okay. Then it produce the flux. That flux is linked with primary and secondary. Okay. Magnetic flux. Then it induce the EMF in primary. So there is a induced EMF in primary and secondary. This is open circuit. Huh? Now if you connect the load here, if you connect the load, then there is a load current I2 dash as referred to primary side. Huh? There is a power factor cos phi 2, load power factor. Okay. So this can be represent in phasor diagram. See. So just first we consider at no load. We neglect this. Then this current is zero at no load. Okay. Only induced voltage, terminal voltage. So actually there is a no drop. Here no impedance, leakage impedance. It means V1 is equals to E1, and if you connect the load, this is equals to V2 also. When there is a load, and this terminal voltage V2, there is no drop because impedance drop is zero. Okay. So it is E2 equals to V2 also. So let us see. There is a, this is vertical axis. We represent as V1 here. Okay. Now this is horizontal axis. Okay. So here we represent the primary parameters. Here it is secondary side. Okay, this side is. So when we apply the voltage, this current is flow, magnetizing current. Okay. So actually it is, if you see, this is a pure inductor. Correct now? When you apply the voltage AC, sinusoidal, then this current is lagged by 90 degree. Now it is a, see this much of circuit. It is a pure inductor circuit. Okay. Your current is lagged by 90 degree. So this magnetizing current is this. That is I mu. That produces a flux in the core. So here there is a flux is produced. It is in phase with current only, phi is proportional to I. So this is your magnetizing flux. Now this flux is come, then there is an induced voltage E1 and E2. They are opposite to V1. Okay, ये 180 degree पे होते हैं. Okay. Why? By Lenz law, it opposes the induced voltage. So now depends on number of turns. There is a E2 and E1. Actually, this are equal, but opposite. It is we write E1 minus V1 equals to E1 minus. Okay, polarity is negative. And V2 equals E2 equals to V2. Okay. Now, if load is connected, Now suppose this load power factor means this ZL, load impedance is inductive load. Inductive means lagging power factor. Then your I2 current, I2 is lag with phi 2. Okay, secondary side voltage it lag. This current is lag. But as referred to primary side, what is the I2 dash? I2 dash equals to KI2. And K is the turn ratio N2 by N1 into I2. Okay? Because we writing na I2 dash by I2 for ideal transformer equals to K. Okay? Please remember. I2 dash equals to KI2. So now as referred to primary side, अब ये हमारा part primary side, this is secondary side. So as referred to primary side, this current will be this na. This is I2 dash. Now there is a two current now. Hello, at this node you apply the KCL. I1 equals to I0 plus I2 dash. But my dear, it is a vector sum because they are in opposite. There is a phase difference between these two currents. So if we do their vector sum, now, sorry, dotted here. So this and this. Their vector sum will we get this one. Okay. So this is the I1 current. Now V1 and I1 there is a phase difference I1. Okay. So now I1 is the primary current. This is your primary load current. Okay. Current at load. And this is your cos phi. If you take na cos phi 1 will be primary power factor. Because there is a two circuit na primary power factor is overall power factor of transformer. Correct? Any doubt here? Hello? No. Now we do some partial ideal transformer, means we neglect the primary and secondary impedance voltage drop in primary secondary, but we consider the core losses, means complete magnetizing circuit. So okay, so transformer with no impedance is 0, so actually there is a, then what is the equivalent circuit? This primary impedance and secondary impedance we are neglected, drop means okay. So here we get a V1, then V1 we apply, then there is a magnetizing branch. Okay, magnetizing branch is this. We have a magnetizing branch. It means there is a primary current which is come, and at this node it is, so at no load this current is completely go here, it is I node, no load current. It has a two component. Okay, it has a two component, I omega I mu, and this is R0, this is X0. Now when this produce the flux magnetize the core, then there is induced voltage E1, and here it is E2. E2 dash equals to E1. Okay. Then at no load here I2 dash is 0. Okay. Then I1 is I naught only, means this. Now I naught has a two component. Active component, active or loss component, okay? And passive or magnetizing component, okay? So it is denoted with I mu. This is I omega. It is actually I naught cos phi naught. This is I naught sin phi naught. Okay, please. These are the two. It is very important question. Two component of I naught. I naught cos phi naught, I naught sin phi naught. Okay. Then if there is a load, if you connect the load here on secondary, now this load power factor, let us generally lagging power factor, cos phi 2 is lagging power factor, okay? Then this I2 is lag with V2, this is your V2. But here actually here there is a no drop here in secondary and primary. It means V1 equals to E1 and E2 equals to V2. But this current is now not zero. There is a load current. Then what is the now vector sum of I naught plus I2 dash vector sum. Okay, clear? So now we draw the vector diagram in this case. Okay, please you refer this circuit. Okay, so in this case, suppose this is your applied voltage, then this is your horizontal axis. Okay. So when you apply the voltage, there is a I naught current is flow at no load. I naught is no load current and cos phi naught is no load power factor. No load power factor. So what is the no load input? No load input power. What is the no load input power? Equals to rated voltage we apply. Then I naught is current cos phi naught. It is denoted by W naught. Actually, it is equals to core loss, iron loss, core loss. Okay. No load input. In open circuit we measure the iron loss. No load input power we assume as a core losses because then this cos I naught we can write no load input power divided by V1 I naught. This will give the power factor, no load power factor. No load power factor. And it is very low at no load because transformer is highly inductive. Then phi naught you can calculate cos inverse of this no load power factor. Then you can take sin phi naught of this then you get a sin. Okay, so you get a cos phi sin phi. I naught we can measure with ammeter. So we can calculate easily this two factors. Okay, correct no? So it means we have a I naught. It is low power factor means it is more lag, a large angle. Low power factor means this angle is large, phi naught. Then there is a two component here, this horizontal and this. Okay, this is I mu. This is I omega, this is I mu. Omega means I naught cos phi naught. This is I naught sin phi naught. Now this is produce the flux in the core. There is a flux phi m. magnetized. Then there is an induced voltage. Yeah, induced voltage E2 E1. It is magnitude is depends on number of turns, but they are in same phase. Now this is equals to V2. Yeah, this is minus E1. Now if there is a load, then I2 secondary. This is I2 current. It will lag with phi 2. So if you know cos phi 2 is power factor, cos phi 2 is power factor. Then you secondary load power, then phi 2 you can calculate cone inverse of this power factor. Suppose it is 0.8, then this angle comes 3687 degree, okay, 36.8. Then you can calculate sin phi 2, it comes 0.6. So again you have this 2. Okay, now as refer to primary side, this current is in opposite direction. Okay, primary side. It is called I2 dash equals to KI2. Now K is here turn ratio. So from K equals to V2 by V1 you can find, or N2 by N1. Now my dear, the vector sum of these two current now. I1 and this angle is I1. Okay, so this is your I1 current. This is your, now they are asking primary current and primary power factor. Cos phi 1 is your primary current. I1 is your current. Okay. Now, but how we calculate I1? So as we resolve ना this I नोट के हमने दो कंपोनेंट लिए हैं already है. This I नोट. Same here, you resolve this I2 dash also here, vertical and horizontal. So you find the I2 dash cos phi 2, and here also I2 dash sin phi 2. It's two component. Okay. Then I2 dash also we calculate two component. I2 dash cos phi 2 versus I2 dash sin phi 2. Now this, now my dear, this two component na, I naught also has a two component. I naught cos phi naught, I naught sin phi naught. Now see, cos term will in same phase and sin terms in same phase. So we calculate total vertical means y along y axis component, and this will give the total horizontal component. Okay. So here I will again draw. Now suppose this two component here add and we get a IY. This two component add here and we get a IX. Now their vector sum. Okay. We get here I1. Okay, I1. Now along this axis, along this axis, there is a V1. It means this angle is phi 1. So in this right angle triangle, please, in this is IX, no? this phasor here to here. This is IY. In this angle, you apply the what is the cos phi 1 here? So it is IY. IY by I1. This will give your primary power factor. And I1 in this right angle triangle, it is a, IX square plus IY square. Okay, my dear. Primary power factor, primary current. Okay, clear now? This is the method to find the primary current, and if no load current is given and full load secondary current is given, then you can calculate primary current and power factor by this phasor. So this portion is very important. So there is no confusion. I share the screen for your reference. Screenshot, screenshot here. Now we come to the question, please. Please. This here fourth B, 4B. This question. Two 235 single phase. This is 230 by 115 volt single phase transformer. Okay. And here it supply a load of 5 ampere, means this is I2 load current. Okay, I2 is 5 ampere at cos I2. Load power factor is 0.86 lagging. Okay, no load current I naught is also given directly here, 0.2 ampere, very low, but at very low power factor. At cos phi naught is very low, as I told, no, very low, 0.208 lagging power factor. Okay. Calculate the primary current and power factor. Understand? So here it is easy. Now diagram already we made, explain. So we do here calculation. Okay. So now if we cos phi naught, okay, is 0.208, then phi naught, please, cos inverse of this. Tell me what is the angle. 208. It comes, angle is large. It comes 78 degree. Then you calculate sine phi naught. Sine on 0.97, 0.97. Okay. 997 or 98 you can write. Okay. 98. Then we can calculate the two component. Okay. Therefore, two component of I naught cos phi naught, I naught sin phi naught. Please, I naught is 0.208 into cos is 0.20. Current 2 ampere, 0.2, sorry. 0.2 into 0.2 into 0.208, and this is 0.2 into 0.98. 0.2. You get a 0.195 ampere, and this is 0.2 into 0.208, 0.042 we can write 0.0. Ampere. Then similarly, cos phi 2 is 0.86. Then phi 2 is cos inverse of this angle. Calculator you required, please. 0.86. It comes 30.68 degree. Then sin phi 2 you get a 0.51. Okay, value. 0.51. Okay. They again and therefore then now there are two component of I2 dash. So first we calculate I2 dash. Okay. For I2 dash we calculate turn ratio or voltage ratio. K equals to V2 is 115 by 230. It is I think 0.5 na. Okay. Then I2 dash equals to KI2. What this is the primary secondary load current as referred to primary side. Secondary current load current as refers to primary side. I2 dash equals to KI2. It is 0.5 into what is the current? 5 ampere na? 5 ampere is I2. Then KI2 you get 2.5 ampere. Okay, I2 days. Then what is the two component of this? I2 days cos phi 2, I2 days sin phi 2. Then it is 2.5 into cos phi 2 is 0.86. This is 2.5 into 0.51. So it comes 2.5 into 0.86. 2.15. This is 2.5 into 0.51. 1.275. Now we add. Okay, and parallelly you draw this circuit. अगर नहीं भी draw करेंगे चलेगा, but you have to require this diagram, phasor diagram. Okay, so like two component of no load, two component of I2 dash, then I1, and now we calculate this one, X1 and Y1 total. Okay. Total vertical component. Vertical means along y-axis. Along y-axis, total component along y-axis means IY. Cos terms you add. Cos term. I naught cos phi naught plus I2 dash cos phi 2. ये दो ऐड हो जाएंगे. And total horizontal means along x-axis. Ix equals to I naught in phi naught plus I2 dash sin phi 2. Now write the values, okay? ये क्या होगा? 0.042 आया था ना? This is 0.042 plus 2.15. This 0.195 plus 2.275. Here 1.47. This is 15. 2.195. बराबर point plus 2.15. This comes 2.192. Okay, therefore, so this diagram is now I1 we can calculate, and then therefore primary load current in primary current I1 equals to Ix square plus Iy square 1.47 whole square plus 2.192 whole square primary power factor was I1. IY by I1. IY is 2.192 divided by here I1 square plus 247 square root 0.83 lagging power factor. Clear? This is the answer. Okay. Point, this comes 2.64. Okay. So please, अभी कहते हैं सर इतना लंबा why we do? Because if we can calculate from turn ratio primary current if secondary current is given. Okay. So you can use K equals to V2 by V1 or equals to N2 by N1 equals to I1 by I2. This is for ideal case actually. ये ideal case में है I1 by 2. Okay. So if you actually it is I2 days by I2 because here now we say assume that I1 equals to I2 days in this for this. Okay, this is for ideally. Practically I1 is you add here I naught also. Okay, and vector sum. Okay, this is actual is this. Okay, from here if you get from here I1 equals to KI2, that is not a I1, it is 2.5, that is I2 days actually. Okay, actual primary current is 2.64, not 2.5. 2.5 is only the load secondary as referred to primary side. You have to add the no load component vector sum. Okay, then you get a clear here. Okay. There was one question was there. I'm like here I tell you. In that you can use the like this one. Hello. This is a voltage single phase supply with a 5 kilowatt. ये वाला क्वेश्चन इसमें टर्न रेशो लगता है यहाँ पे 440 by 110 है यहाँ पे 220 है. ठीक है. Which one you want? Here you can use the turn ratio. Why? Why? Please. Because here it is written, ignore the transformer power losses, means it is ideal transformer. Okay. So here transformer load of transformer supply load. This is a load in kilowatt. So what is the secondary load? Load on secondary of transformer. Load on secondary. क्या है 5 kilowatt. at 0.8 power factor. Can we decalculate? Therefore, secondary load current क्या होगी बताइए? I2 your kilowatt load into 1000. Yeah, okay. Then single phase है तो V2 cos kilowatt है, power factor also. Okay, correct. ये होगा 5000, 5 into 1000, 5000 divided by 110 into 0.8. How much you get? 1000 divided by 56.82 ampere. I2. You get I2. Then he asks you calculate the primary and secondary currents. So this is secondary load current now and primary load current. Please. So use a turn ratio. K equals to N2 by N1, V2 by V1 equals to I1 by I2. This is for loss free transformer. Okay. So here we can write I1 equals to KI2. So what is the K? K is V2 means 110 by 440 V2 by V1 into I1 is 56.82. So here this ratio is 1 by 1/4 of this. Sorry. 14.2 ampere. Okay. This is the question. Small. Okay. Clear? Okay. Now this is the old question. Here it is also asking same thing. You try to solve it. Okay. जरा start कीजिए. Okay. Maybe they ask. It was already needed. See, turn ratio rating is given. So what is the no load current? Single phase no load current is given. Core losses. Core losses means no load input. So actually here no load power factor is not given. No load current is given, but cos phi not given. So you can calculate from no load input. It is HT side is energized at rated frequency. So at no load, your primary side we energize with rated voltage, means we apply here 2400 V1 and then it take a no load current and the second we kept open. Then what is the no load input? No load input is V1 I naught cos phi naught, that is 700 equals to core loss. Okay. So cos phi naught we can calculate W naught by V1 I naught. Okay, so 700 by 2400 into 0.64. क्या करेंगे आपको ये? Then you sin phi naught you can calculate. Then he asks two component of no load current. I naught आपके पास है, then इसके दो component निकाल लीजिए. यहीं पे आपका half question solve हो गया. Then now we say that secondary current load current दिया 40 ampere at cos phi 2 0.8 lagging power factor. Lagging मैं just brief कर रहा हूँ. लेगिंग पावर फैक्टर। देन हम साइन फाइव नो 2 निकाल लेंगे है, वो 0.6 होगा। अभी ये I2 है तो I2 डैश यू कैन कैलकुलेट बाय टर्न रेशो KI2। ओके, KI2 10 आएगा, ये देखो V2 by V2। व्हाट इज द K? V2 by V1 इक्वल्स टू, तो ये 1/10, K इक्वल्स टू 1/10 होगा। व्हाट इज द I2 डैश? 1/10 into 40, 4 एम्पियर आया, 4 एम्पियर। ओके so now again two component of I2 dash। okay, two component of I0, two component I2 dash, then same, आगे same है। okay, ignore leakage impedance means वो नेग्लेक्ट कर रहे हैं, तभी तो ये डायग्राम आया। क्लियर? तो आगे का सेम इज दिस, two component, then I1 cos phi1 he is asking। clear? hello, okay, so here you try it, I give the 5 minutes। okay, then we discuss the three phase transformer, because sometimes they can ask the three phase question also। okay,
एक्सक्यूज मी सर।
yeah,
सर वो डेरिवेशन पार्ट आप ग्रुप में डाल सकते हैं क्या सर? मेरा मिस हो गया, मैं लॉग इन लेट किया मैंने सर।
डाल दिया ऑलरेडी, देखो।
अच्छा, ओके, थैंक यू।
then back by yes please। Okay, now we see here, this is the diagram at ideal transformer. This I have represented. Then this was the used to calculate the current. Okay, this one is the transformer on load, assuming voltage drop is no voltage drop means impedance we neglect 0, primary and secondary. So there is no drop in the winding. Equal primary and secondary turn. Here it is they assume the equal turns. That's why this E1 equals to E2 also. Okay. Now we come to, already we discussed everything. Now we come efficiency. Sometimes they are asked you. Okay. Output by input. How we calculate our input? Output plus total losses. Already we solved the questions on efficiency. Okay. What is the condition for maximum efficiency? So here the question are different type of losses in transformer. Please note down this. So due to winding resistance, copper losses, that is called variable loss. That depends on the load. But core loss, iron loss are consist of hysteresis and eddy current loss. These are their empirical formulas. Please note down. On which factor they are depends, the voltage and frequency. The iron core losses are depends on voltage and frequency. How we minimize the hysteresis and eddy current loss? By using high permeability core, steel, silicon steel core, laminated core. Okay. This is a question, different type losses in transformer. Now condition for maximum, derivation not asked, but write when copper loss equals to iron loss. तो at a particular load, suppose 100 kVA ट्रांसफॉर्मर है, हम एक्चुअली देखिए मोटर है, अल्टरनेटर, और इफ पावर ट्रांसफार्मर विच इज यूज एट पावर स्टेशन और ट्रांसमिशन लाइंस में जो यूज होते हैं ट्रांसफार्मर, मोटर्स, दे आर डिजाइन, they give the maximum efficiency, higher efficiency at full load condition, when there is a full load. Okay. But distribution transformer na, hello, distribution transformer, the load on the distribution transformer is fluctuate. You know, in peak hours, like it is morning 8 a.m. to 10 p.m. maximum load. Then during night hours, load is reduced, or it is depends on season wise, winter, summer. So like a 100 kVA distribution transformer, their maximum efficiency may be at 80% load or 75% load, not at full load. We design such that it gives the efficiency at some partial load, because average load. So at a particular load, see it is asked here sometime. If you know the full load means rated kVA. Sometime they ask you how we calculate the, if suppose 100 kVA transformer, then what is the kVA load in kVA at which the transformer give maximum efficiency. So if you know the full load copper loss and iron losses, then rated kVA into iron loss by full load copper loss root multiple by this. You get a load at which two losses are equal means maximum. इसको इस तरह से लिख सकते हैं means what is the kVA load है kVA load in kVA or kVA load corresponding to maximum efficiency. Okay, maximum efficiency equals to rated kVA आपका जो क्या है rated kVA into if we should know the full load iron loss and full load copper losses. If you know the full load copper loss, it's called copper loss, but it is a full load copper loss. Okay, full load loss. Okay, into this rated kVA into this ratio. This will give you for distribution type. So we can determine the load in kVA at which transformer gives maximum efficiency. Therefore, we define the all-day efficiency for distribution transformer means we take a time means how much kilowatt energy we consider energy now output kilowatt hour to input kilowatt hour. Now three-phase transformer. So there is a comparison. Sometime ask, what is how we make a three-phase? Either we use a three identical single-phase transformer. We make a that is called bank of three transformers. Bank of three transformers, or a unit transformer. Three-phase unit means we use a three-phase core. It's like this. Okay. In three phase connection are star star, delta delta, star delta, or open delta. Open delta na their capacity is reduced by 1 by root 3 times. Okay. These are the different type of connection. Now you know on board. On board we use basis of three phase. As you write na, there was one question, explain the star delta connection, write basic equation. So what is the line voltage which is between the line? Phase voltage across the phase winding or line and neutral. So these are the equation for star connection. Line voltage equals to root 3 times of phase voltage and line current equals to phase current. For balanced delta, here voltage are equal line and phase, but current is line current equals to root 3 times of phase current. These things only 6 marks question में यही लिखना है आपको. Okay. Now three phase transformer play the important role because our power generation to distribution it in three phase. So we required a three phase transformer. How we made a three phase transformer? Construction. So three phase unit transformer first. ये सेकंड को छोड़ दीजिए हैं प्लीज. एंड थर्ड सी है कॉमन कोर मीन्स यूनिट थ्री फेज ट्रांसफार्मर आई थिंक. एंड दिस आर द थ्री फेज कनेक्शन. मैंने शायद आप लोगों को शेयर किया है वो थ्री फेज बैंक और उसमें डिफरेंस भेजा है क्या? मैं भेज देता हूँ. आई पुट ट्रांसफार्मर क्वेश्चन. जस्ट अ मिनट प्लीज. अभी तो था. This difference is asked, so I share here. Hello. बैंक ऑफ ट्रांसफार्मर एंड यूनिट ट्रांसफार्मर, ये ओल्ड ईटीओ में क्वेश्चन आया था. ओके, व्हाट इज द डिफरेंस बिटवीन द, हम वो डिस्कस करेंगे क्योंकि एक्चुअली लार्ज ट्रांसफार्मर है, उसको ट्रांसपोर्टेशन इंस्टॉलेशन पोर्टेशन लोडिंग अनलोडिंग में दिक्कत है, वो इट इज असेंबल्ड एट साइट है. But three small units you can easily transport, but their installation is costly because you need to install three. But there is a operation and maintenance point of view, there is a advantage in a three base bank, because out of three only one time is one transformer is damaged due to short circuit if there is a fault, so we need replace only one small unit. But if unit transformer में three phase core transformer, if it is damaged then complete unit you have to replace. And spare part की बात करें तो this small unit they can, spare parts are identical, तो same spare we can use. Okay. ट्रांसफार्मर के भी क्वेश्चन है, आई एम जस्ट वेट है, वर्किंग ऑफ थ्री फेज इंडक्शन. यहाँ पे भी यही है, ट्रांसफर वर्किंग प्रिंसिपल पैरेलल ऑपरेशन ऑफ ट्रांसफार्मर वर्किंग कंडीशन आ जाएंगे. ओके, आई शेयर हियर थोड़ी पार्ट आई हैव शेयर. ओके, यू रीड दिस कंडीशन फॉर पैरेलल ऑपरेशन थ्री फेज के लिए है, डिजायरेबल एंड एसेंशियल दे आर आस्किंग, ये ओल्ड क्वेश्चन थे. ओके, so these are the connection है स्टार स्टार डेल्टा. नाउ इन थ्री फेज टर्न रेशो की बात करें तो हम पर फेज डिफाइन करते हैं. ओके, सेकेंडरी फेज वोल्टेज बाय प्राइमरी फेज वोल्टेज. नाउ इट डिपेंड्स इफ इट इज स्टार कनेक्टेड, स्टार कनेक्टेड, एक्चुअली डेल्टा डेल्टा में आपकी फेज वोल्टेज इक्वल टू लाइन वोल्टेज ही होती है. ओके, so there is nothing change, but when it is star delta delta star, then you please put the phase values. Okay. There was one question on this three phase. देखिए ये यहाँ पर टर्न्स हैं, तो टर्न्स रेशो पर फेज ही होते हैं टर्न. देन their primary if star delta connection delta star connection, you can calculate the secondary voltage, line voltage it is. So first you convert the primary current into phase, then you apply the phase turn ratio, you can transfer the, so actually values given always in line current, line voltage. Okay, when we do the calculation we do per phase calculation, but you write the answer again in line, in terms of line voltage. So then you need to observe the connection, it is star connection or delta connection. Okay. Like this, a container ship has a three phase delta, you know, on board we use a delta. There is an advantage of delta. If suppose one transformer is one winding is damaged, then we can operate in open delta. There is it is suitable for unbalanced load. there is no third harmonic is eliminated in delta delta. Okay, that's why. So this is the voltage ratio, delta delta connected. Feeding heavy power on 440 volt. Primary current, line current is given. Then he asks what is the secondary power factor is given. Then he asks calculate the current in each coil. Each coil means phase current. And kilowatt output of transformer. So your secondary side you calculate the voltage, secondary side current you calculate. Then kilowatt power is V2 I2 cos phi 2 root 3, three phases, and is 3 V2 I2 cos phi 2 kilowatt के लिए divide by 1000. Okay. इसके लिए क्या करेंगे? सॉल्यूशन 6 है. तो यहाँ पर आपकी डेल्टा डेल्टा कनेक्टेड है. ओके, प्लीज मेक द कनेक्शन. Diagram will help you to in calculation. Okay, see this is secondary side connected to load. यहाँ पर लोड पावर फैक्टर भी दिया है आपका cos phi 2. It is cos phi 2. It is 0.8 है lagging. And here voltage is 440 volt. V2. Then I2 we calculate. Okay, line. But on primary side voltage is given, line voltage है. Primary line voltage ये है आपका 6600 volt. Then current is also given here, line current. Primary line current है 100 ampere. So here it is current in per phase, I phase. Here current in per phase, I2 phase. This is I2 line current we calculate. So here you write for delta, दोनों भी डेल्टा है तो डेल्टा कनेक्शन के लिए you write line voltage equals to phase voltage, but line current root 3 times of phase current. Okay, please. So actually what is the primary phase voltage equals to primary line voltage जो होगा वही होगा primary phase voltage, that is C1 phase. V1 phase is 6600. Okay, then similarly secondary phase voltage वो भी डेल्टा साइड है. यहाँ पर भी V2 phase भी is your 440. ओके, अगर ये स्टार होता तो रूट 3 से डिवाइड कर देते हैं. ओके, then we can calculate per phase or phase turn ratio. K equals to V2 phase by V1 phase. So it is 440 by 6600. यहाँ से टर्न रेशो आएगा. Then अभी we can now current primary आपको primary line current is given, line current. Okay, I1 line 100 ampere. So what is the I? Therefore, phase current I1 phase equals to I1 line by root 3 for delta. That is 100 by root 3. ये कुछ 56 पॉइंट भी आएगा. 100 divided by root 3. Oh, sorry, for 57. 57.74. Okay. Now, by using the turn ratio, what is the turn ratio? V equals to per phase turn ratio. That is V2 phase by V1 phase equals to I1 करंट अपोजिट होती है. करंट क्या हो जाएगी? I1 phase by I2 phase. तो यहाँ से from here we calculate a secondary phase current. Secondary phase current. That is I1 phase by K. I1 phase जो 5747 आया उसको डिवाइड बाई what is this ratio? 440 by 6600. It comes 0.067. 0.067 से मल्टीपल किया था 57.74. This comes 866.1 ampere. This is the current in each coil. Current in each coil per phase current. ये प्राइमरी में करंट है. करंट इन each coil of primary, current in each coil of secondary. Okay, phase current. Then line current. ये हम secondary line current निकालेंगे. line current. So for delta I2L equal root 3 I2 phase. इसको root 3 से मल्टीपल कर देंगे. This comes ideal. This comes 1500 ampere. 1500 ampere. Okay. Then you calculate kilowatt output. Kilowatt output of transformer. The secondary line current and voltage is given. What is the power? Root 3 V2 line by I2 line cos pi 2 divided by 1000. Root 3 into 440 into I2 is 1500 RPM into 0.8 na power factor divided by 1000. एक कितना आ गया? जाएगा आपका 44 into 50 into 0.8 to root 3. It is come 914.52 ampere. This is the kilowatt power. Okay, by this you do the calculation like this. Okay, you observe the same here. Turn ratio है, but you know the connection. Phase values you calculate, then you put the turn ratio per phase. Okay. Okay, bye. Now alternator we tomorrow we complete alternate synchronous machine. Okay.
सर इवनिंग में क्लास रहेगी क्या सर?
इवनिंग में आज कहीं रहेगी.